Okay, everyone, welcome back. In today's lesson, we're going to talk about chemical reactions and how to write them. That shows how the chemical reaction takes place and making sure that they are balanced with the right number of atoms on each side of the equation. Now, there are names that we use for the products that combine together or react together. I shouldn't be so specific. And the stuff that we are left with. So the chemicals that react with one another, surprisingly, are called reactants. And when they go through their chemical reaction, they give you products. So we have reactants, and the reaction takes place, and then we get products on the right-hand side. Now, we can write chemical equations in different ways. The first type is using a word equation, where you write the names of the chemicals that are reacting with each other. So, for example, we can say hydrogen plus oxygen gives us water. So that is an example of a word equation. Hydrogen plus oxygen gives us water. We then have, so let me write word equation so it's clear for everybody. We can then write something which is called a skeleton equation. And I'll explain why it's called skeleton. A skeleton equation shows you the formulas of the reactants and the products, but it is not balanced. So hydrogen is H2 in its natural state, and oxygen is O2 in its natural state, and water, we all know, is H2O. Now, the reason we call this a skeleton equation is please look at the number of atoms of each element we have on the left-hand side and on the right-hand side. So let's count atoms. How many hydrogen atoms do we have on the left-hand side? So remember, we use the 2. So we have 2 hydrogen atoms on the left. We have 2 oxygen atoms on the left as well. However, on the product side, we have 2 hydrogen and 1 oxygen. Now that is not a complete equation because, as we know, the conservation of mass says that the number of atoms on the left-hand side should equal the number of atoms on the right-hand side. We can't just cause one of the atoms to just disappear. So in this case, that is why it's called a skeleton equation. It's because it is not complete. It's only the bare essentials. A complete balanced equation is where we actually have the number of atoms on the product reactant side equaling the number of atoms on the right-hand side. And there are rules as to how we do it. What you also should realize is that I haven't stated what state hydrogen and oxygen occur. Usually we refer to the natural state in which they occur. So in this case, hydrogen in its natural state is a gas. So we would put H2 and then we'd put a G between parentheses next to it, stating that hydrogen here is a gas. Same with oxygen. It is a gas. And then, water that forms is then a liquid for L for liquid. Should we have a solid in any of our equations, we would depict it with an S. So we have gases depicted with a G, liquids with an L, and should we have solids, we would use an S. Now there are rules to how we can balance an equation. So let us work with the simplest one, which was the creation of water, using hydrogen gas, oxygen gas to form the liquid water. The first thing that you should do is try to figure out what coefficient you should need to use on each side of the equation in order to balance it. I will walk you through the first one, and then we'll start going through more difficult ones as we try to go along. So in this case, I have the 2 hydrogen atoms. I have 2 oxygen atoms. Here I have 2 hydrogen atoms, and I have 1 oxygen atom. So let's look at each atom on its own. 2 hydrogen, 2 hydrogen. Great, we're balanced. Let's look at our oxygen. We have 2 oxygen and 1. What would we need to multiply the 1 with to make it equal 2? That is 2. So what you would need to do is put the coefficient 2. By doing that, you now have changed oxygen to 2. But hold on. By putting a coefficient 2 before H2O, you're also affecting the number of hydrogen you have in the product side. Now, this changes to 4 hydrogen. So let's go back to the other side. We had 2 hydrogen here and 4 hydrogen here. What do I need to do or put in front of the hydrogen gas here in order to get 4 hydrogen? It should be a 2, because then this will change to 4 hydrogen. Now let's double check. 4 hydrogen, 4 hydrogen. We have 2 oxygen, 2 oxygen. We have now balanced our equation. So our complete equation would look as 2 hydrogen gas plus oxygen gas gives us 2 water molecules. That is an example of a balanced equation. Now, should you have more than just hydrogen and oxygen? So let us consider a case of the reaction between aluminum and oxygen. So let us now delete all of this, and let's try an equation with aluminum, which in its natural state is a solid, with oxygen gas to give us aluminum oxide. So, looking at this, let's count our atoms on each side of the equation. We have 1 aluminum, 2 oxygen, and on the product side, we have 2 aluminum, 1 oxygen. So obviously, we do not have a balanced equation. However, what do you start balancing first? A very good helpful tip when balancing an equation is always leave oxygen or hydrogen until the end. Now, in the case of water, where you only had hydrogen and oxygen, you know what, in that case, you can just start with either one. But in this case, we have aluminum and oxygen. Always leave the oxygen until the end to balance it. It is much easier to do it that way. And always try to balance the atom that has the highest or greatest number of atoms in the equation. That's another helpful hint. So let's look at aluminum. So if we're going to leave oxygen until the end, we have to look at aluminum. We have 1 atom on the left, 2 on the right. So what coefficient do we need to put before the aluminum in the reactant side? We have to put 2. By doing that, we now have 2 aluminum. We have 2 oxygen, that stays the same, and we have 1 oxygen here. Now, let us look at oxygen. We have 2 here, we have 1 here. Okay, so that's not going to work. There are 2 ways of solving this. The simpler way is to say, well, in that case, I need to have 2 oxygen on the product side, which means that I have to put the coefficient 2 before aluminum oxide. Now, if I do that, I've now affected both numbers. So now I have 4 aluminum and 2 oxygen. So what do I have to do now? I'm still not balanced. I have 2 aluminum here, I have 4 aluminum here, which means I now have to change the coefficient of aluminum from 2 to 4, and that would make this 4 aluminum. Now I am balanced. I have 4 aluminum on the left, 4 on the right, 2 oxygen on the left, 2 oxygen on the right. It is a bit tricky at first, but honestly, it is very simple once you get the hang of it and you start balancing more and more equations. Let us try another one. I think the more that we practice this together, the better off we will be in being able to solve it. So let us try calcium and nitrogen to give us calcium nitride. So in this case, let's look at products and reactants. We have 1 calcium. Oh, and I should specify calcium is a solid, nitrogen is a gas, and calcium nitride is a solid. Calcium, we have 2 nitrogen. In this case, we have 2 calcium and 2 nitrogen. So just from looking at this, it looks like the nitrogen going well. We got 2 nitrogen, 2 nitrogen. But we have 1 calcium and 2 calcium here. Easiest way to solve that is to give calcium in the reactant side a coefficient of 2. That only affects the calcium. We end up with 2 calcium, and we are balanced. That's a very simple one. Notice our equation is balanced. 2 calcium on the left, 2 on the right, 2 nitrogen on the left, 2 nitrogen on the right. So the best way to make sure that your equation is correct is to count the number of atoms on the product side and on the reactant side. If they are not equal, then you've made a mistake somewhere and you need to start over again.